Hi there, welcome to this video where we'll be adding some rocks to this map. At the moment what you see is just the landscape, the basic landscape mesh. I was inspired by the video from Hogwarts, well, the new game called Hogwarts Legacy, in which there is a scene where a dragon flies over the island, and I just thought it looked like a cool island, especially with the dragon. So I thought, well, I could use it as an example to add some rocks with the USurfaceMesh plugin to where the cliffs would be. So let's first of all just have a look at the map without any static meshes added as cliffs on the side. Change to wireframe mode. It does have tessellation on the landscape, but it's just the pure sculpted landscape at the moment. So whenever parts of the landscape become vertical, then the vertices can stretch out. The polygons can also stretch out. At the moment, this particular material is a landscape material which was purchased off the marketplace, an auto material, and it has triplanar projections. Therefore, the moment that them polygons go vertical, then it uses the projection from the side to view the rocks. I'll just turn on VSync. And if we hit play, then I've just added in this dragon from the marketplace as well. Just added a few basic facilities to it. So at least we can fly around and have a look. And as you can see, there's no static meshes on the side of the cliffs at the moment. Thought I'd work on the dragon to give some functionality to flying around. I just thought it looked quite cool. So what I plan to do is to capture this this surface and then move it into ZBrush so that we can actually sculpt using the advanced tools in there. You can use the Unreal's or Epic's Unreal modeling plugin in the editor, which does allow for some basic sculpting. It's not the easiest tool to use for sculpting, but it has an excellent use of the editor, so therefore you have the existing camera movement as well. Whereas in ZBrush you have superior modelling tools, but yet the camera doesn't allow for like an in-game camera. So that, you know, in ZBrush I find it quite difficult to move the camera around to make it look like you're actually in a game. Instead it just looks like a you know, a modelling tool instead, which is exactly what it is, of course. The other thing we can always do as well is, before we actually capture the raw surface of the landscape, we could always bring in some Quixel meshes and then add them to the sides of the cliff, and then at least the detail that's in them will then be captured into the surface that we capture with the USurfaceMesh plugin. So to do that, let's switch to Quixel Quixel Bridge actually. Right, so in Quixel Bridge I've typed in rock and cliff, so we've now got a few models that have come up. And so I'd just be looking for something that would provide sort of like on the edge of the cliff some sort of rollover, sort of like on the edge and then down into the vertical part. It doesn't matter about whether it stretches down all the length of the cliff, because we can always layer up other meshes just below that. So something like this is quite good. Sometimes when it comes to capturing the surface, it can be quite difficult to capture hollows like this, because the vertices from the USurfaceMesh are projected from a flat plane, and if they can't penetrate into those hollows, then you end up with stretched polygons. So let's keep scouting for something that's appropriate. Some of these ones down here are quite good. These ones have quite a nice smooth rollover onto from the grass plane at the top to the vertical part, so I think we'll get something like that. You can also get a few more as well. Like I say, it's all about layering other things up, other meshes up. Doesn't matter about the colour of the mesh. We're just looking for the actual surface detail. We'll add our own material on top of the mesh, something like this. That's quite a nice one. So once we've downloaded some of these, then we can export them out. As you can see with some of these meshes here, these have got quite significant hollows, so you can end up with stretching on some of them. So now that we've got a selection of meshes, we'll switch back to Unreal. So now we'll drag in some meshes and just see what works really. Let's filter it for static meshes, and then we can just go and drag some of these in now. In a way, this is a form of sculpting, just with meshes. That's all. This is just to change the surface that gets captured. So you can always spend your time trying to create a unique shape. It doesn't really matter about repetition, because in ZBrush we can always sculpt on top of this to add more detail. This is just to block out essentially what we actually want. There are some of these meshes that lend themselves quite nicely to stretching out as well, create quite a unique shape. It's just a case of taking your time, see what works. So once we've actually got some sort of area covered, maybe just blocking this little bit here. Just want this to protrude out and then down. But once you've got something that looks reasonable, then we can try and capture this. So then what we can do is we can bring in a USurfaceMesh grid actor. So we'll go up to search classes and type in USurf, and then we can bring in USurfaceMesh grid. This then is a panel that allows you to expand a grid mesh. So if you create the mesh, then you can see that it actually produces a mesh with the number of quads that you specify here. So if we want 20 from the center to the top, then there'll be 20 there, and then 5 at the bottom, which is there. So if we switch back to the preview mode, then we can specify a large area to capture. So if we go to the right, maybe 20, to the left 20, to the top 5, maybe 10, and then we can increase the dimension scale. So instead of each quad being a meter by a meter with a complexity of 1, so that means produce a polygon per 100, or produce a vertex per 100 centimeters. So we can say we'll make it 10 times bigger than that. So now it'll be produce a vertex every 10 meters. So if we go 5, so let's produce a vertex every 5 meters, but then if we increase the complexity to 5, that means we go back to producing 1 vertex every 1 meter again. So then we can create the mesh. So this has 40,000 polygons in it. And if we view that as a mesh, then that's what it looks like. So now we can choose to capture this from a particular angle. So you want something that's going to capture the surface correctly, and you also have to make sure the complexity is going to capture its detail as well, which at the moment, because it's only 1 vertex every 1 meter, if we choose capture there, then as you can see there is not enough detail to capture all of the surface. So the reason you end up with these stretched polygons here is because they have a maximum projection length, which if we go down to project, so it projects 100 meters. So if we increase this to 1000 meters and then recapture, so it gets a full projection now. The other things that can interact with the projection are the channels. So at the moment, inside of project settings in collision, we've set the projection channel to USM project, and at the moment there are some objects in here which the oceanology water is interacting with the USM project channel. So what we need to do is actually go and locate there is a trigger box here, and at the moment in its collision section it is told to USM project is on ignore for that one. Right, so the lake water is told to block the projection, so we can ignore that. So if we try that again, so there's something else that's interacting with that. So in this case, it's probably just going to be easier just to move the ocean out of the way and then recapture it. So we'll increase the complexity So this has now produced 640,000 polygons. So now if we choose capture height again, then we can also go shift after to 50. So that means it will shift up along the z-axis, the local z-axis, by 50 centimeters. So as we can see, that that is capturing from the point of view of the plane projecting down. So we have to, as you can see, it's causing some stretching, but that's okay because we can fill in that detail anyway and smooth it out. So the question at the moment is there enough detail captured? So if we increase this maybe to 30, let it rebuild the mesh. So that's 1.4 million polygons. So if we go capture again, you don't have to capture such a big area. You can always create it in sections if you like. So there we go. So we're starting to capture more and more detail now. But we're also extending out the amount that we're capturing, because you have to remember that we're wanting to sculpt certain parts of this and then place it back into the world, into the level, exactly as this one is placed. So at the moment the origin is set where this USurfaceMesh plugin is. So if we want to change that, you can do it at a later date with the modeling plugin from Epic, but at the moment the origin will be set there. You can always move it closer, but that's with the risk of the plane interacting then with the landscape and clipping through it and things like that. And like I say, you can spend more time as well, because you can move these around, these meshes around, to stop as much stretching, and you can fill in all of this other area around here. And as well as that, on the right hand side, we're not actually capturing any of this here. It's hard to do it all in one because obviously you can't wrap round, so you end up having to cut off certain areas. But if you you'll see when we actually put it into ZBrush that you can create a fairly optimized mesh that only fits where you want it to fit. So all of this, where the ocean is, the ocean bed, and any parts that are not needed can always be clipped out. So at the moment what we'll do is we'll just remove this shift because we want it sat on the surface of the landscape. So we'll just let that rebuild. And once it's actually sat on the surface, then you usually end up with this Z fighting because the polygons are in exactly the same location. So now what we need to do is need to stamp the mesh. So at the moment the LOD group is not important. We just have to choose the location where we want to stamp it to. So if I've already created a stamped meshes folder here. So you can create whichever folder you want. And then we'll create a name, which at the moment is set to name with number. So whatever name you add here, it'll append a number on the end of it. So if we just tell it to do name only. And then we'll choose stamp mesh. So that now converts the procedural mesh into a static mesh, saves it into your asset library, and and then replaces the plugin, the procedural mesh in the plugin, with the static mesh. So what you actually see in the level now is the actual static mesh. So if you click on it, you'll see that it is a static mesh actor, the static mesh component with the static mesh actually loaded into it. So if we view the static mesh on its own, then you can see that this has 1.44 million triangles. And you can see it's a very, very dense mesh. So this is just like any other static mesh. So what we can do now with it is we can browse to its location inside of the asset browser, content browser. We'll just go File and Save All, so we'll make sure it is saved. So what we can do now is we can right click the asset, choose Asset Actions and then Export. And then what we want to do is we want to specify a location on your computer as to where to save this FBX file, which we will later then import into ZBrush. So I'll do that now and then I'll see you in ZBrush. So here we are in ZBrush. So what we want to do now is go to Z plugin and then FBX export import, and then we want to import the file that we've just exported from Unreal. So we just choose import. So what you need to do is go and select the file and it should import automatically. So now that we have that file imported, it's been loaded in onto the right hand side tool panel. So we can just drag inside of the viewport from the center down. And then now we can choose Edit. And then we can choose right click and hold down to rotate. And then we use Alt, right click to pan it around. So then we can press your left control key and then right click to zoom in. So now that this mesh is in here, we can use all of the tools that ZBrush has. As you can see, the projection lines show that it was projected from an angle. You could always rotate that so that it projects more flat on to the surface. It may capture more detail in that case. But what we want to do now is actually change the mesh that's on the surface, so we have to retopologize it. So you can use things like under geometry you can use Tessimate. So if we specify a size here that we want to Tessimate it to, then it's just based on what detail you're looking for really. That then gets us good geometry to sculpt onto again. Usually what I do is I now, you can either go and create, you can start sculpting this particular mesh, but the problem with that is that if you were to sculpt on a part that, say like here, where you would end up causing it to raise up, you wouldn't know where the surface level is. In which case, if you then try to optimize it by cutting away some polygons, then you may end up in the situation where you end up with polygons that are raised above the landscape. So when you come to import it back into your level in Unreal, they're floating up in the air, which you can deal with as well, because you can use the sculpting tools inside of the Epic's modeling plugin to move them around. But another way to do it in here is to duplicate the tool, the subtool. So we go duplicate, and at the moment we're not in solo mode, so we are seeing both meshes. And what we can do is we can turn on colorize, and then we can go to a different material, and if we go to one of them and treat one of them as the base, then we can actually choose a colour. I like to use this dark green colour, and we can choose fill object, and then we can switch to the other one, and we can just fill that with a different colour, which maybe fill it with pure white, and then we can switch our material back to something else. So now if we get hold of the one that's the extra, the one that we're going to sculpt onto, and we go down to geometry and we go down to deformation, then we can go down to inflate. I seem to remember it's inflate. I don't know whether it's inflate balloon or not though. Let's try inflate first, and we can say minus 0.1. So that forces the mesh underneath the original mesh. If we go to the edge, you can see that it's gone down by 0.1, which equates to that much in ZBrush at the moment. So now what we can do is, because we have that, is you could save that as a new project. So that's under File and then Save As. So that then becomes a project. At least that's your starting point then for creating a mesh. If we continue on with just a little bit of sculpting, so I've got the clay build-up tool here, and we go on to Subtool, make sure we're on the one that we're actually going to sculpt. Make sure that the Z intensity is low enough to not really add too much. Then when it comes to actually sculpting, you can now just sculpt onto the surface, and it's like adding rock now, but you can see where you've added it. So wherever it's green, it's as it was captured from Unreal, from your level. So you can see like there, I've just gone over the edge, so we just press Alt, and then we can force that back under the edge again. So it's up to you as to how you want to add these sorts of things. Just a case of building it up. You usually just think about land, the way that it's built up in layers. Sometimes it can be quite difficult to get enough detail into, purely sculpted with basic alpha brushes in ZBrush. And then we can increase the Z intensity. We're not adding enough detail. And occasionally you will get this stretching, which if we turn on polyframe, then we can see that it does introduce stretching because the tessimate is not active. So therefore it doesn't re-tessimate as it goes. You go to geometry and then tessimate again. And it just keeps recalculating each time. So I would try and add enough detail, just where you actually want the rock. then we can also do things like fixing these stretched out bits. And the bits that weren't filled in correctly. Basically like just adding rock to the surface. If you imagine, it's like icing a cake. It's what makes sculpting in ZBrush quite nice, really. It's visually pleasing, I would say, to feel as though you're painting rock onto the surface. So once we've got something that looks about what we want, then we can decide where we want to cut off this particular mesh, because obviously you don't really want to wrap it round the side, because it may be more appropriate to actually create another one for that side. And we've got to think about the optimization of this as well. So there's various tools that we can use to optimize the geometry, and then we've also got to think about, you know, what materials are going onto the surface, how much detail they're going to need. Are we using things like tessellation, or is it just world position offset, or are we just relying on normal maps? So other things you can do is you can also go to use other tools like Trim Adaptive, which allow you to, as long as your Z intensity is low enough, allow you to cut in and down to create more detail. Just make sure that you don't do big cuts, because sometimes it can cause geometry problems. Sometimes if you don't have enough detail, you just need to switch back to adding more in. the good thing about doing it this way as well is you can also add in details that you wouldn't really think about. So say like if you wanted something overhanging or to loop over, so say like over here, I'll turn on Sculptris Pro at the moment. If we add some detail here, which is then significant, and get it to protrude out, then we could also create like either a big overhang or we could try and use some of these other tools to create something that actually comes away from the surface and then down. Then maybe we want to expand into some sort of big cave. Just a case of experimenting and see what works really. So then we can continue to use these other brushes as well. So then the other thing you can do is you can always use various alpha textures, which these are the orb brushes. So we've got orb rock here. Something just to displace the surface. Which you can create your own brushes from Quixel as well, the height displacement textures. So if we want to add more detail, we can always just subdivide the mesh. So we could run Tessimate, and then we could just have a look at the number of polygons that we've got, or the number of points that we've got, 1.7 million, so we can divide that. So we now end up with tons more. And then once we've got something that we quite like, then we can now choose to get rid of everything that we don't need. So to do that, what we'll do is we'll use the selection actually. Yeah, we'll use the selection. We'll delete the hidden. So if we go select lasso, so this is use Control Shift keys to control this. So then what we'll do is we'll select a part of it. That should then only, so if we choose solo, that should only select that part. Then we'll invert it and get rid of it. So at least now if we go around and select only the part that we actually want, then everything else can be trimmed away. So we have to delete the lower subdivision and then delete the hidden. So if we now solo that, then we can see that we get a mesh that that is only the part that we selected. So with areas like this where we forced this underneath the ground, is I always have difficulty trying to merge these two. I seem to remember it's with Dynamesh that you can merge them. So it can just be easier just to get rid of what we don't need. So if we just select the parts that we don't need. So now that we've got that, we can spend more time and actually clear out all the areas that we really don't need that are over here. We can create a much tighter mesh then. You spend much more time doing that. So once we've got this, then now what we need to do is we have to think about the mesh. So the actual mesh as it is, we've got to think about how we're going to unwrap it, and also what resolution we want the mesh to be. So if we have a look at polyframe, we can see what density it is. So we could always switch to using decimate. So if we go pre-process current, then we can go back to choosing how many polygons we actually want, which, you know, for something that would maybe be like that, I would maybe want 40 or 50,000, so maybe 200,000 on here would be okay. So this is 200,000 polys, so if we choose decimate current, then what this does is it optimizes the mesh so that the whole amount takes up fewer polygons. Too many as it is there, so Z plugin. So let's go to maybe 100,000. Yeah, so something like that. Maybe what we should actually do is go to 200,000. Yeah, that's what it should have done before, but it didn't. So so once we've got 200,000, then we can choose whether that is the correct detail or not. And we can always trim away some of the things as well. Now you can either unwrap it in ZBrush, or we can export this to Blender and then do it in there. You could always use the Epic's modeling plugin to unwrap it as well. So for now, let's just get it exported from here and back into Unreal again. So to do that, what we do is go to Z plugin, go to FBX export, import, and choose export selected, and then choose export, and then save that to a location on your hard drive again, which you can then choose to import as a new static mesh into Unreal. So I'll see you in Unreal in a minute. So now that we're back into Unreal Engine, we can choose add an import, and then go to import to re-import our sculpted mesh. So I'll do that now and see you in a minute. So inside of the FBX import options, I generally just leave all these as they are. You don't want to be creating any materials or importing any textures. And as far as generating missing collision, you got to think about how you would want to collide with the mesh, really, because you can always create a simplified collision, or you could generate that in Blender. So for now, just leave it as it is. Don't generate the collision. And we'll leave skeletal mesh off so that it'll import as a static mesh. So sometimes you may get import warnings or errors. So here it says that the mesh has some nearly zero normals, which can create some issues. So any kind of normal issues, really, you can sort out in Blender. You could always regenerate the normals inside of Unreal as well by going into the static mesh. and then going to build section settings, and then choosing recompute normals. So now what we want to do is we want to use a feature of the USurfaceMesh plugin which allows you to import a static mesh and place it exactly where the existing static mesh is in the level. So to do this, what we need to do is go into the existing mesh that's there. You don't really need to use the existing one. You could always use the existing mesh that was stamped, which in this case is the Island Cliff 1. So that original static mesh. Because if you right click on that and you show, go to Asset Actions and then choose Show Metadata, inside of here it contains all of the information about how the mesh was produced. So this is what the USurfaceMesh plugin uses to know where it was produced and how the mesh was produced. So what we can do is, if you actually look at the one that we imported where we sculpted it, then that one doesn't have any metadata. So what we can do is we can use one mesh to copy over to the other mesh using the plugin. So what we can do is go to either the one you already had in the level, or you could just add another one. And then what we need to do is we need to remove this static mesh that's here. But if you just go ahead and click that static mesh and then choose delete, it'll tell you that it's going to break references. So we'll just say no. And what that means is that inside of the plugin, if we go down to link, then we can see that here, when we stamped the mesh, it automatically added to this recreate mesh actor a link to the actor in the level. So if we clear that out, then we can now remove that actor from the level without destroying the references. So what we need to do now is we need to use this link section to load in a mesh that we want to place. So we want to place in the sculpted version. And we also want to, on place, copy the metadata from the original one. So we'll use that as the metadata mesh. And then what we do is we just go up to the top and then we choose place mesh. So that now is placing in the sculpted mesh in place of the original mesh. And it pasted it in, or placed it in, exactly as the original one was. So now if we go ahead and actually remove all of the static meshes that we use to sculpt the mesh, then now we end up with our new sculpted version in place. And of course it's up to you to choose how you would like to unwrap such a thing. Bring back the ocean as well. So at the moment, because this doesn't have any collision, then we technically can fly through the mesh. So if we wanted to change that, we could either, like I say, use Blender to create a simplified mesh, or for now we could always use could always go into the static mesh and then choose collision complexity to be use complex collision as simple, which means we would actually use the geometry, the actual polygon geometry. So technically we shouldn't be able to fly into it now. No. Should be able to fly through it. So what we can do now is you can always see how the modelling plugin would be able to unwrap such a thing. If we went and added a new material to this. So I think I already have a material set up for the mesh, which is in the USurfaceMesh content folder. You have the materials folder, and inside of here you have base materials, and then you have a base RDA mesh material, and this is the one you use on meshes. This allows you to paint using the red, green and blue and alpha channels, and the equivalent for the landscape is the landscape base there. So I've already created that using created a material instance of it using this MI mesh 1. As you can see, its parent is base RDA mesh from the plugin. So this allows you to load in layers basically for red, green and blue and alpha. So if I just add that to that mesh, then as you can see, there's stretching all over this. So you could either use triplanar, so inside of here you could turn on use cheap world aligned. You could turn that off so that it's full world align instead of top down. In fact, in this case that's probably what we'll do. So to get this to match the landscape, because I've used an auto material, it would mean matching whatever is in this material. If you were using a virtual texture, then you could write out this material to a virtual texture and then read it into this material. Just create a customized version, so that would mean copying this to your own folder and then going into it and then adding your own read of the virtual texture. So what I've done now is I've gone ahead and created that copy of the base RDA mesh material from the plugin. I've called it a custom base RDA mesh, and what I've done is I've added into the world a runtime virtual texture volume, which writes out the landscapes material to an RVT. And if we look at the landscape auto material, where you would have the normal output there to the output of the material, instead what it does is it just breaks it up into the runtime virtual texture output, and then we immediately read that virtual texture back again, the RVT landscape texture, and then we output that as the material instead. So what that allows us to do is inside of the custom base RDA mesh, what we can do over here is where we would normally read in layer 1, which would be where it's not red. So we're using a height blend material attributes here, and its input for its transition is the red channel. So wherever it's not red, we would normally read in this layer 1. Whereas now what I've done is I've made it read in the runtime virtual texture, and then I've put it through a switch to say use virtual texture as base. So if we're not doing that, we'll just go via the normal route. Inside of the map, it required setting on the landscape the draw in virtual textures to render out to that RVT. So you've got the volume that encompasses the landscape, which has the runtime virtual texture in it. You've got the landscape been told to output to that runtime virtual texture. You've got the landscape's material, which outputs to that runtime virtual texture and also reads from it, and then that outputs the actual material onto the surface then. So other things that I was able to do is inside of the custom base mesh, because we are using that RVT now, then that means that essentially you can read it, but what I've done is I've made it so that we blend in to get the grass on the surface. We blend into what is layer 2, so the green. We blend in the grass using the auto materials version of creating that grass, which is the base there. And we blend in a variation to make it so it matches better. So further down the line, we also change the specular to a custom specular as well. So a few edits inside of the base RDA mesh material. So the other thing I utilised here was the USurfaceMesh paint actor, which again, if you type USurface in, you can get USurfaceMesh paint. And inside of this particular tool comes as part of the plugin, and it is for painting meshes that have already been stamped. They're already static meshes. They're no longer part of the USurfaceMesh grid actor. They're not procedural. So to use this, you add one of these USurfaceMesh paint actors to the level, and then you specify the static mesh that you want to change using the target mesh actor, and then that allows you to then manipulate the vertex colours or render out any kind of information about the surface to textures, and also manipulate the parameters to do with those surface values. So here what I've done is I've actually rendered out to the red channel, first of all, the surface angle. In fact, it was an inverted surface angle, so it selected everything that was vertically up at 0, which would then make that white, and then because we inverted it, it made it black, so only everything on the edge was 90 degrees perpendicular to that, with a fall off of 60 degrees, was white, brown to grey. And so then what I did is I then preserved those colours, because that painted into the edge the the runtime virtual texture. And then I switch to preserving those red colours, and then switch to painting in the green colour as the surface angle, which then gives us the rock on the side. So to get the rock on the side, I just utilise the existing material instance to load it up with the grass from the auto material into layer 2, and then the cliffs into layer 3, which is the blue channel. So if we go and have a play now, you can see the rocks on the right hand side that were created using the existing meshes. And if you need to make any edits, then you can always use the Epix modeling plugin. I think it's quite a good result for fairly minimal work. There's no grass on the surface at the moment because that would require painting in via the foliage tools in Unreal. But with more work you could have a much better result as well. And then of course around the side here you could then do the same again to fill out all of that. So I hope you enjoyed this tutorial, demonstration, whatever you want to call it. It's the technique that I use to create custom rocks on the surface. And I think it produces quite a nice result, like I say, for fairly minimal amount of work. It's certainly the technique that gives you the best ability to, like I say, essentially paint, sculpt rock onto the surface using ZBrush. But it's a nice way of capturing the surface and then custom sculpting as you want it. And of course, the more vertices you throw at it, the more time you take, the better result you'll get. And then of course the other thing is the materials. You know, Quixel has a massive library of materials. It's just a case of experimenting and seeing what works for you. But thank you for joining me for this one. I'll see you in the next one.